Today we're going to talk about polynomial division, dividing polynomials. But before we get there, let's look at ordinary division with numbers. Let's suppose I want to divide 5 into 16. Well, 16, we call that the dividend. That's what you're dividing into. And 5 is what you're using to divide into 16. We call that the divisor. So we know 5 goes into 16 3 times. And we multiply 3 times 5 gives you 15. And you subtract 15 from 16 to get 1. 5 can't go into 1, so 1 is our remainder. And 3 is what we call the quotient. So in other words, 16 divided by 5 is equal to 3 with a remainder of 1. Or we could say 16 divided by 5 is equal to 3 and 1/5. So notice 5 is the divisor, 3 is the quotient, 1 is the remainder, and 16 is the dividend. So let's put this all together. So we had 16 divided by 5 is 3 plus 1/5. In other words, the dividend divided by the divisor is the quotient, is equal to the quotient plus the remainder over the divisor. Now if I multiply everything by the divisor, what we end up with is, the dividend is the quotient times the divisor plus the remainder. Now this is the basis of polynomial long division. If you think of the dividend as the function we want to divide into, so think of dividend as f of x. Well, let's say we divide that f of x by a divisor called d of x. Well, f of x is going to be equal to d of x times the quotient, and the quotient is what you get out when you're doing the division. So the quotient, q of x, times the divisor d of x, plus your remainder, r of x. And we call this formula the division algorithm. Note that if you have no remainder, that means that your divisor goes evenly into your function, and it's a factor of the function. So we'll see more of that later. So let's use this division algorithm and proceed into polynomial long division. So let's suppose we want to divide the polynomial 6x cubed minus x squared minus 5x plus 4. Divide that by 3x minus 2. Well, we use the same rules as long division. The first thing we're going to look at is how many times this lead term here, 3x, is going to go into this lead term, 6x cubed. Well, 3x goes into 6x cubed. It seems like 3 goes into 6 2 times, and x goes into x cubed, x squared time. So we have 2x squared. So 3x goes into 6x cubed, 2x squared time. And how I know that, if I multiply 2x squared times 3x, I end up with 6x cubed. And we keep multiplying. 2x squared times minus 2 gives me minus 4x squared. Just like division now, we do a subtraction. So remember, we're going to subtract these two here. And 6x cubed minus 6x cubed will give me 0, which it's supposed to do. And then minus x squared minus x squared plus 4x squared gives me 3x squared. So the next thing we do, just like in long division, is we bring down the next term, which is negative 5x. So we go negative 5x. And now we see 3x, how many times does that go into 3x squared? Well, it goes into it 1 and x. X goes into x squared x times. So we'll have a plus x here. Multiply this plus x by the 3x to get 3x squared. It should always be the same term in front. Then x times negative 2 gives me minus 2x. Again, we subtract these. 3x squared minus x squared is 0. Minus 5x minus 5x plus 2x is negative 3x. Then we bring down the 4, so plus 4. And now we divide 3x into negative 3x. Well, that's minus 1. And we multiply back through by the minus 1. Minus 1 times 3x is minus 3x. And minus 1 times minus 2 is plus 2. And then we subtract them. So minus 3x is 0 again. 4 minus 2 gives me 2. So there's our division. And so this is my quotient. 2x squared plus x minus 1 is the quotient. My divisor was 3x minus 2. And 2 is my remainder. So let's put that all together. And so we have 6x cubed minus x squared minus 5x plus f4, this is my function, is equal to, well, we divided by 3x minus 2. So that's my divisor, d of x, times the quotient. The quotient we got was 2x squared plus x minus 1. So 2q of x times d of x plus my remainder of 2. And so we've used the division algorithm to break down this polynomial f of x. Now, what if my divisor, 3x minus 2, what if this number were a factor of my polynomial? Then we wouldn't get a remainder. And we'll see that as we go on, that's what we're looking for. When we divide by a factor, we don't get any remainders. Now, this type of long division sometimes can be cumbersome. So we're going to see an easier method to divide polynomials if what you're dividing for, if your divisor is linear, if it's a linear divisor, and more specifically, if it has the form x minus c. And so if it has this form, c is a constant, x is just a variable x, we can use what's called synthetic division. So let's see how synthetic division works.